Section 11.5 talks about or and problems, okay? So let's take a look here and see if we can't figure these out. So this is going to be the probability of A or B. So this is obviously an or problem. And it says to determine the probability of A or B, we're going to use the following formula. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so let's see if we can go through that. It says each of the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 are, or is written on a separate piece of paper. The 10 pieces of paper are then sealed in a hat, and one piece is randomly selected. Determine the probability that the piece of paper selected contains an even number or a number greater than 6. Okay, so let's think about this. So we're going to have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so the first part says determine the probability that the paper has an even number. Okay, so guys, A is going to be the event that we get an even number. Okay, B is going to be the event that we get a number greater than 6. Okay, so the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so let's see if we can figure out the first part, the probability of getting an even number. Okay, so let's think about this for a minute. Okay, even numbers. So we know we have a total of 10 numbers here. We're going to figure out how many of those numbers are even. Well, 5 out of 10 are even. Okay? So now, let's do the same thing plus the probability of B. So how many numbers here are greater than 6? Well, those 4 numbers out of 10 are greater than 6, minus, what's the probability that we're going to get an even number that is greater than 6? So if you notice in here, we have those 2 out of 10. Okay? So now we're just going to go ahead and go straight across. So let's see, 5 plus 4 is 9. 9 minus 2 is 7. Okay? So guys, we have to subtract the probability of both because if you notice, we counted the numbers 8 and 9, or I'm sorry, 8 and 10 twice, right? All right. So let's see if we can do another one. Let's take a look here. It says, consider the same sample space. The numbers 1 through 10. Okay, so let's think about those numbers again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now, the first part says determine the probability that contains a number less than 5 or a number greater than 8. Okay, so A is going to be a number less than 5. B is going to be a number greater than 8. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both of them. Okay. So, first part, numbers less than 5. So, numbers less than 5, there are 4 of them. So, 4 out of 10. Okay. Now, next part, numbers greater than 8. Plus 2 of them. Okay. Minus, do we have any numbers that are at the same time smaller than 5 and greater than 8? No, because you can see that the 2 boxes that we have are not connected. So minus 0 out of 10. Okay. So 4 plus 2 is 6. So 6 out of 10, all we're going to do is reduce it, divide them both by 2, and we end up with 3/5. Okay. Now, these are what we call mutually exclusive events, right? Mutually exclusive, it says it's impossible for both events to occur simultaneously. So if you notice, again, there was no numbers that were both less than 5 and greater than 8, okay? All right. Let's take a look here at the next one. Let's see. So the directions are asking me here. It says one card is selected from a standard deck of playing cards. Determine if the following pairs of events are mutually exclusive and determine probability of A or B. Okay, so we're going to find two things. Number one, are they mutually exclusive? And then number two, we're going to find their probability. So, can we have an ace and a 9 at the same time? So again, guys, if you forgot what a deck of cards looks like, oops, here we go. So here's my aces, right? And here are my 9s. And nope, there is no ace and 9. So those are going to be mutually exclusive. So I'll tell you what, let's find the probability of getting an ace. Oops. And let's get the probability of getting a 9. Okay, so 4B. Okay. So the probability of getting an ace. Let's come back to our picture. Okay, we have 4 out of 52. And the same thing for getting a 9. We have 4 out of 52. Okay, so we can actually reduce these fractions here. So 4 out of 52 is going to reduce to 1 out of 13, plus another 1 out of 13 is going to give me 2 out of 13. All right, so there's my answer for part A. Let's do part B. Can we have an ace and a heart? Okay, so let's come back and look at our picture. Here's the aces, here's the hearts. Yes, we can have them both, right? Okay, so probability of getting an ace or a heart is going to be the probability of getting an ace plus the probability of getting a heart minus the probability of getting both of them. Okay. So we know that there's 4 out of 52 for aces. For hearts, again, if I come back to my picture, look at the hearts. 1, 2, 3, 4. It looks like there's 13 of them, right? There's 13 of each suit. Okay. So 13 out of 52. Okay. Minus how many heart aces do we have? We only have one of them, right? This one right here. Okay. So minus 1 out of 52. Okay, I'll give you a hint. That's going to be 52. So 4 plus 13 is 17. 17 minus 1 is 16. Okay. And now let's reduce our fractions. So let me get my calculator here. There we go. Turn this guy on. Okay. So 16 and 52, we can divide them both by 4. So 52, I want to say divided by 4 should give me 13, right? Yeah. So 4 out of 13 would be our answer right here. If we divide both of them by 4. That's not a very pretty 4, so let's fix that. There we go. Okay. Probability of getting a red card. Probability of getting a black card. Okay, so are they mutually exclusive? Yes, because we don't have any red-black cards, right? They're either the cards are black or they are red, okay? So, they're going to be mutually exclusive. So, the probability of getting a red card or a black card is going to be probability of getting a red plus the probability of getting a black. Okay. How many of them are red? Half. How many are black? Half. What's the probability? 1. You're guaranteed to get either a red or black card, right? There's no other options. Okay. Okay, and then there is a part D, so let's do part D as in dog. A picture card and a red card. So first, let's see, are they mutually exclusive? Are there any red picture cards? Yes. Those 6 are red picture cards right over here on the bottom, right? Okay, so if we're going to find the probability of getting a red or a picture card, we're going to say, what's the probability of getting a red card? What's the probability of getting a picture card minus the probability of getting a red picture card, okay? So remember, we have a total of 52 cards. 26 of them are red, right? And we have a total of 52 cards. We're going to figure out how many of them are picture cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 picture cards. Okay. And then we have to subtract the overlap. How many of them are red picture cards? 6. 6 out of those 52. Okay. So, again, I know that's 52. So 26 and 12 is 38. 38 minus 6 is 32. Okay. Again, if we divide them both by 4, that's going to give me 13, and that's going to give me 8. And so there's my answer, right? All right. So let me keep scrolling down here, guys, to the next part. And this one says the probability of A and B. Okay. So it says the probability of A and B is going to be equal to the probability of A times the probability of B. Okay, so it says 2 cards are to be selected. Notice what it says here, with replacement from a deck of cards. Determine the probability that 2 spades will be selected. Okay, so the probability of getting a spades the first time and the probability of getting a spades the second time. Okay, so again, I know we have a total of 52 cards. So what I'm going to do is I'm going to say how many of them are spades. 13 of them are spades, right? So we have a total of 13. Okay. Now, the second time, we are replacing it, right? So whatever card we pick, suppose we pick the 4 of, let me see if I can draw a spade. I probably cannot, so you can laugh if you want to, but that's not nice. I'm just kidding, guys. Okay, suppose I pick the 4 of spades, right? We pick that card, we're going to replace it. That means that that 4 is going to go back in the deck of cards, right? So we still have 52 cards, and we still have 13 spades. So guys, if we divide both of these numbers by 13, that's going to give me 1/4 times another 1/4. That's now going to give me 1/16, right? All right, now look at the next part. It says 2 cards are to be selected without replacement, okay? What's the probability that 2 spades will be selected? Okay, so we're going to get a spades the first time, and we're going to get a spades the second time. Okay, so we already said that there's 13 spades, and we have 52 cards. But again, if we picked the 4 of spades, right? I know that's not a pretty spade, but you get what I'm trying to do, right? We are not going to replace it, right? So that card is out of the deck. So if we used to have 52 cards, now we have a total of 51, right? And if we had 13 spades and we've got one the first time, now there's only going to be 12 spades to choose from, right? Okay, so guys, again, I know I can divide both of these by 13. That's going to give me 1/4 times 12 out of 51. Now that 4 will go into that 12 3 times. And I bet you we can still reduce 3 and 51 by 3. So let me take my calculator again. 51 divided by 3 is 17. Yes, it is. Okay. And so we end up with 1/17, right? 1/17. Okay. So moving along here, it says independent events. It says events A and B are independent events if the occurrence of either event in no way affects the probability of the other event. Okay, So it says, the first problem we have here says 100 people attended a charity benefit to raise money for cancer research. 3 people in attendance will be selected at random without replacement. Okay, this part's important. Without replacement. And each will be awarded 1 door prize. Are the events of selecting the 3 people who will be awarded the door prize independent or dependent events? Okay, so we have 100 people, right? The chances of you getting the prize the first time is 1 out of 100. The second time, the chances are 1 out of 99. And the third time, it's 1 out of 98, right? Because we are not replacing it. So if J-Lo, again, because I'm going to choose her, is at this event and she gets chosen the first time, they're not going to let her get the second one, right? Because it's without replacement. So you got the first prize, you can't go again. So these are going to be what we call dependent events, okay? The reason being is that the probability of the second and the third are dependent on the one prior to that, right? Your probability changes, okay? So, guys, typically, before I go on, anytime we have without replacement, those are going to be dependent events, okay? All right. So now let's take a look at the next problem we got here, and it says, a new medicine was given to a sample of 25 Dr. Cleary's patients with flu symptoms. Of the total, 19 of them reacted favorably. 2 of them reacted unfavorably, and 4 were unaffected. Okay. 3 of these patients were selected at random. Determine the probability that all 3 reacted favorably. Okay, so part A, all reacted favorably. Okay, we have 25 patients. The probability that the first person is going to act favorably is 19 out of 25. Okay, then we're going to pick a second person. So now we only have 24 people to choose from, and there's only 18 of them that are going to react favorably now because we've already chosen one of those. Now we only have 23 people to choose from, and again, this is going to be 17, right? Guys, all I'm going to try to do here is maybe reduce my fraction a little bit. I bet we can divide both of those numbers by 6. So this is going to give me a 3. That's going to give me a 4. And then we're just going to multiply the rest of it straight across. Okay, so let's go 19 times 3 times 17 is 969. And then the bottom is going to be 25 times 4 times 3. 25 times 4 times, not 3, but 23, I'm sorry. 2300? No, 2875. I put 4. I put 5, I'm sorry. That doesn't seem right. 25 times 4 times 23 should be 2300, right? There we go. 2300. All right. Now part B. So let's do part B. Okay. So part B says, the first person reacted favorably. Okay, so the first person acting favorably is 19 out of the 25. Okay. The second person acted unfavorably. So we have 24 people to choose from. 2 of them have not yet been chosen. So 2 out of the 24. And the third patient, so now again I only have 23 patients to choose from, are unaffected. And it looks like we had, 4 that were unaffected? Okay. So again, I'm going to try to reduce where I can. So 2 and 24 reduces to 1 over 12, and 4 and 12 reduces to a 1 and 3. Okay. So look, we have 19 on the top, 25 times 3 times 23. Let's do that. So 25 times 3 times 23 is 1725. Okay. All right, part C says no patient reacted favorably. Okay, so no favorably. Okay, so we have 25 people. If they're not going to react favorably, that means that they're either going to react unfavorably or unaffected. That's a total of 6. Okay. So let me just bring this down a little bit. There we go. Come on. Let's see. Okay. So the first time we're going to have 6 out of 25, then 5 out of 24, and then 3 out of 23. Okay. Guys, I'm going to do the same thing we did earlier. I'm going to try to reduce my fractions. Okay. So let's see. 5 and 25 reduced to 1 and 5. 6 and 24 reduced to 1 and 4. And I cannot reduce the 3 and the 23. So let's see. 1 times 3 is 3 times 3 is 9. And 5 times 4 times 23 on the bottom. Grab my calculator again. 5 times 4 times 23 gives me a total of 460. Okay, so that's going to be my denominator. Okay. All right, and then part D. D is in dog. At least one patient reacted favorably. So guys, when we already know the probability that none of them reacted favorably, the way we're going to find the probability that at least one, we're going to take 1 minus the answer that we got from the previous part. Okay? So I can think of that as 460 over 460 minus 9 out of 460, and that's going to leave me with 451 out of 460. Okay? And there's my answer for part B. So let's keep scrolling along here. Let's see. Okay, so let me read this problem here. It says, exam preparation. Professor Connell is in charge of a program to prepare students for a high school equivalency exam. Records show that the probability of the student in the program needs help in math is 0.07 or 0.7. The probability that they need help in English is 0.6, and the probability that they need help in both in math and English is 0.55. Determine the probability that a student needs help in math or English. Okay, so this is math or English. Okay, it's going to be equal to the probability that they need help in math plus the probability that they need help in English minus the probability that they need help in math and English. Okay, so here we go. The probability they need help in math, 0.7. The probability they need help in English, 0.6. The probability they need help in both, 0.55. So let's calculate it. Okay. So clear that out. 0.7 plus 0.6 minus 0.55, 0.75. And we're done. Okay. All right. So we got a few more to do here. Let's try these out. And it says in exercises 19 through 22, let's see, a single die is rolled one time. Okay, so guys, when we roll a die, remember the choices we're going to have are 1, 2, 3, 4, 5, and 6. Okay, so the first part says number 19. What's the probability we're going to get a 5 or a 6? Well, out of the 6 numbers we have, how many of those numbers are 5 or 6? So let's see. 2 of them are going to be either the numbers 5 or 6. So 2 out of 6 is 1/3. Okay. Number 20. an odd number. So how many are odd numbers? 1, 2, 3. Okay, so odd numbers is 3 out of 6. Okay, or a number greater than 4. A number greater than 4 right here, plus 2 out of 6 minus, which is the one that we counted twice? Well, we counted the number 5 twice. That's one number that we counted twice, okay? So 3 plus 2 is 5, minus 1 is 4. 4 out of 6 is the same as 2/3, right? Okay. So let me do this, this, and that. Okay. So now, 21, a number greater than 4. So numbers greater than 4 are these. Less than 2 is that one. Okay. So 21, number greater than 4, 2 out of 6. Plus numbers less than 2, 1 out of 6. That is 3 out of 6, which is the same as 1/2. Right? Okay. Get rid of that and that. And then now let's try number 22. A number greater than 3. So numbers, okay, numbers greater than 3. Those are numbers greater than 3. Okay. Numbers less than 5. These are numbers less than 5. Okay. So how many numbers did we have greater than 3? 3 out of 6. Plus, how many numbers were less than 5? 4 out of 6. Minus, which one did we count twice? The number 4, that's one of them. So 3 plus 4 is 7. 7 minus 1 is 6. So 6 out of 6, same thing as 1, right? Okay. All right. Let's take a look at numbers 41 and 42. Okay, let's see. The first part says, if the spinner is spun twice, determine the probability that the pointer lands green then red. Okay, so guys, again, I'm going to think of this as green. Okay, so what's the probability we're going to land on green? 2 out of 4. Plus, and then red, 1 out of 4. That's going to be, oops, my mistake here, guys. Let me back this up. My mistake. Okay, first green, then red. So first green is going to be 2 out of 4 times the second time, because we're doing this 2 times, my bad. Second time, then red. So how many are red? 1 out of 4, right? And so that's going to give me 2 out of 16, which is the same as 1/8. Okay. So this is for number 41. And then number 42, red on both spins. So the first time I get red, I have a 1 in 4th chance getting. If I get red again, it's going to be another 1 in 4th chance getting. So that's going to be 1 out of 16, okay? So it's supposed to be multiply, not add. Sorry. Okay. All right, so last 2 problems. Let's take a look here, see if we can't figure this out. So let's see. I'm going to make sure that my circle looks good. There it is. Okay, so that circle is cut up into 8 equal pieces. So for 43, we want to get red the first time. So red the first time is going to be 3 out of 8. We're going to go red the second time, another 3 out of 8. That's going to give us 9 over 64. Okay. And then for number 44, it says a color other than green on both spins. So out of the 8, it looks like 2 of them are green. So that means 6 out of 8 are not green. 6 out of 8 are not green. Okay. So let's go ahead and reduce those fractions. We divide them both by 2. 3/4 times another 3/4. And that should give us 9 over 16, right? And that's how we do and and OR probabilities, guys.